Okay, so we're going to do an activity to kind of review everything that we've been talking about and really focusing on with probability. So we know that the more times that we do an experiment, the closer the experimental probability, or relative frequency, as we've been hearing it called, comes to the theoretical probability. Remember, the theoretical probability, that's what we expect to happen. And the experimental probability is what actually happens. We have to collect data. Something has to be done for an experimental probability. So we're going to see this play out in a real example. I have a cute little dice that I had made. It's lovely. And on my dice, my theoretical probability, again, what I would expect for my dice, if I want to roll a number 1, there's only one on a dice out of 6 total sides. My theoretical probability of rolling a 1 is 1 out of 6. And then the number 2, there's only one 2 on my dice. So I would expect that 2 to come out 1 out of 6 times. Again, all sides of my dice have the same probability. There's only one 3, there's only one 4, there's only one 5, there's only one 6 on a dice. So the probability of rolling any one of these numbers is going to be 1/6. It's all going to be the same. Now we're going to do an experiment. I'm going to roll my dice 6 times, and I'm going to put a tally mark for every time one of those numbers appears. So I got a 6. I got a 4. I got a 1. I got another 4. I got a 3. And I've got a 5. So I've rolled my dice 1, 2, 3, 4, 5, 6 times. So my experimental probability right now is going to be, after my 6 rolls, I rolled a 1 time out of 6. 2s, I didn't roll any 2s, so my probability there was 0 out of 6. My 3, I rolled 1 time, so I rolled that 1 out of 6 total times. I rolled a 4 2 times, so that's 2 out of 6 rolls, which can simplify if I divide them both by 2. I get 1/3 for the probability of rolling a 4. A 5 was 1 time out of my 6 rolls, and then a 6 was 1 time out of my 6 rolls. So if we take a look, rolling the 1, that matched. Rolling a 2, my experimental and my theoretical probability, they did not match. My 3 probability matched. My probability of rolling a 4 did not match. My 5 and my 6, they both matched. So now we're going to roll some more. We're going to include these tallies from before. So I'm going to keep that 1, don't have any there. Keep that 1, keep those 2, keep that 1, keep that 1. And now I'm going to add on to it. So I've already rolled 6 times, but now we're going to go to 24. So I've got another 1, another 1, a 2, a 5, 11 rolls, 12, 13, 14, 15, 16, 17, and there's my 24 rolls. So now let's check and see, is our experimental probability the same or is it going to be different? So now after my 24 rolls, 6 of them, of the 24, were equal, or is how many I rolled. We can simplify that. Divide by 6. And I get 1 out of 4. For my probability of rolling a 1. For my probability of rolling a 2, we have 2 out of 24, which can simplify if I divide by 2. And I get 1/12. Probability for 3 was 5 out of 24. For 4, again, was 5 out of 24. Probability for 5 was 3 out of 24. I can simplify that. If I divide by what number? 3. And we end up with 1/8. And for 6, again, I rolled that 3 times, which we saw right there, simplifies to 1/8. Again, I would expect all of these to simplify to 1/6 because that's my theoretical probability. So if I wanted it to become 1/6, how many out of 24 rolls would that be? How many would I expect it to be if it was 1/6? 6 times 4 is 24. 1 times 4 then, I expect 4 rolls, but none of my tallies match up to 4 rolls to equal 1/6. None of them match up anymore. So let's keep going to 60 and let's see if we can get closer to that 1/6. Or actually, sorry, let's turn these into decimal forms. It's a little bit easier to compare decimals than fractions. So if I pull out my calculator, I see that 1/6 is equal to 0.16 repeating. So 1/6, that's equal to 0.16 repeating. 1/4, that's 0.25. So here my 1 is more than what it should be. 1/12 is 0.083 repeating. This 2 is way lower than that 0.16 repeating. 5 divided by 24, that's 0.2083 repeating. Again, that's more than what I expect. Same thing here. And then 1/8 is 0.125. Again, those are close for the most part. This one's pretty far off though. And let's see if we keep rolling to 60 times, if we can get those numbers even closer to that 0.16. So we're going to keep the same from before. So I've got 1, 2, 3, 4, 5, 6 here, 2 there, 5 there, 5 there, 3 there, and 3 there. So that's 24 total rolls. Now I'm trying to get to 60 rolls. So right now, if you look, all 4 of these are even. This is one less, this is one more. Do you see how they're starting to even out? And now I just realized I forgot how many rolls I'd done. 5, 10, 15, 20, 25, 30, 32, 34, 37, 38, 39, 40, 41, 42, 43. That doesn't add up. 5, 10, 15, 20, 25, 30. One more roll. So now after my 60 rolls, 10 out of 60, which simplifies to 1/6. Again, 10 out of 60, which simplifies to 1/6. Here we have 9 out of 60. What number can go into 9 and 60? 3. So we get 3 out of 20. In decimal form is 0.15. Again, that is very close to what we expect, which is that 0.16 repeating. This one we had 11 out of 60. In decimal form, we get 0.183 repeating. Again, very close to that 0.16 repeating. And then our last two were another 10 out of 60, which simplifies to 1/6. 10 out of 60 simplifies to 1/6. So out of all those numbers, 4 of them are exactly matching the theoretical probability. And then these two, this was one more roll, this was one less roll than what we would expect. So as we saw here, the more we did our experiment, the closer our experimental probability came to the theoretical probability. If you look at this, it's crazy. 2 had 0 rolls, then 2 rolls, and then it caught up and matched everybody else. That's crazy, but that's what we see when we do experimental probability. So if we come down here and look at the question, it says, what do you notice about the change in the experimental probability from 6 rolls to 60 rolls? And that's exactly what we just talked about. The more we did the experiment, the closer the experimental probability came to the theoretical probability. And that's the biggest thing that we want you to take from this unit right here. This is very important. We've attached this paper, so if you have a dice at home and you want to do the same experiment to see how your numbers play out, you can. I also made it so that if you want to use a coin, you can use a coin to flip heads and tails and see how your flips come close to the theoretical probability. And as always, if you need anything, let us know.